Okay, so for today's dissection, we are going to be looking at a clam. They are part of the family Mollusca, and so you can see this is our beautiful clam. We can see the stick that's actually propping the mouth open. And so we're going to take a look at the external anatomy of our clam first. So this is going to be our hinge ligament right here. This is a really tightly strung ligament. It keeps the mouth of the clam or the clam shell shut when there are predators so that they can't get in. At here is the umbral, and then we see our growth lines. So each one of these lines going down are actually growth lines. So just like in a tree, they're going to grow. Now, they're not all even, and that's because of nutrients. So the more nutrients the clam has, the better growing conditions it will have, and then the bigger the clam grows. On this side, we can see that there's going to be our look to our mantle, and then here is going to be a valve right in this area. But our first step is going to be to open it. Remember, when we start looking at our clam shell, we want to make sure that we're looking at our right and left valves are going to be on our sides, and then we're going to look at this as well. But we're going to scrape some of this off. So what happens with a clam is, because it does live in the ocean, things will start to stick to that clam shell, and so it's not really exposed. So this brown stuff is not normally what is being made. And so we can see if our clam shell reacts just a little bit here with an acid. And if you can see, it's not really clear on the video, but we have a little bit of bubbling going on. And so this is really important too, to note that this is a calcium-based clamshell. So that's kind of fun. If we would have hydrochloric acid, it would bubble much more. So we do have some of that where we can see that bubbling and that scraping away, and it will bubble as we scrape away. It's still actually bubbling under my finger. So in order to get this, we want to look at some of the layers of the clamshell, and so I have a little piece that's removed right here. And so we can see that it's not a very thick layering, that there is some of this calcium part built into it. But we're going to go ahead and open our clamshell. When you open your clam, this hinge ligament needs to be cut, otherwise the clam is not able to be opened. We have two muscles on the anterior adduct muscle, or adduct muscle, and the posterior adduct muscle. And so we have to cut those, and we cut those by coming in on the side here and moving our scalpel to remove that muscle. We don't have to cut through that shell on this side, but we do have to remove that muscle. If it is really strenuous, you can use a lever like a screwdriver here, but if you have good hand muscles, this was already propped open for me, we can simply take and start to open this. You can see how I've already cut through the muscle on this side completely, but I'm having a little bit of residual, so I'm going to look at this side, and I have not completely cut through that muscle. And so I'm going to want to take my scalpel and go a little deeper, and making that cut. Then we're going to see that this opens up. It was propped open with a stick, so we can take that stick out. If I was in a classroom, I would tell you to take and run distilled water in this to get any of the particles out, but we are not going to do that. We will always have part of our mantle that will stick up here to the shell, so I'm removing that. That is part of the mantle. You can see that the muscle wasn't completely cut right here, and so because of that, I'm going to want to finish cutting that muscle all the way through. And then we can see our muscle was attached in two spots as I lay my shell open. We can see the two muscles, the adductor muscles, the adduct muscles. Those are what's keeping our clam shut. So on this side, because I have it kind of backwards, this is the anterior and this is the posterior. So the anterior is easy to find. If we see our umbrum right here, it's the one closest to that umbrum. And then the posterior is the one furthest away. Anterior means towards the front, posterior means towards the back. And we can see how part of the mantle is connected right here to the bottom of our beautiful shell. Now this is that nitron that we're talking about, that beautiful material that they go through when you make necklaces and beautiful jewelry out of. That's what this is. I'm actually going to break our shell apart at the hinge ligament here and set that one off to the side so that it's out of the way. Now what we have is the inside of our clam. We've seen both the anterior and posterior muscle, and from here we can see a few more things. If we look right here before removing anything else, we have our foot. We have our top part right here. This is the mantle. Underneath of that you can start to see the visceral mass. And from this you can see that we do have siphons on the side that allow for water to go in and out. And so those are really important to identify as we start going forward, so we know what we have. The foot, by the way, can leave the shell. It actually will pop out through this side to help with locomotion as we go through. You do have a sheet in your lab that talks about structural units, but right now we know where our AD muscle is, our abduct muscle, and we are going to look at some of the other things underneath of our mantle here. So right now I'm going to peel this back really nicely. I don't want to use a scalpel because I don't want to damage material, so I'm going to use the scissors. And I'm going to gently remove this piece of mantle. You can see right here how there's a nice coloration between the two, and you can see the connective tissue that's holding these together. You can almost see, I'm going to hold that up for you, a translucent line. See how it's coming off? That's how we know it's not part of that, so we can actually cut this piece off. And this is part of the mantle. Underneath is our visceral mass, and this is just a nice thin layer for the mantle. It usually doesn't have a coloration to it, but the coloration could be part of the preservation process and the age of the specimen itself. I'm going to finish cutting the rest of this mantle off so we can expose everything underneath. And now we can see some other materials or some other things that we have here. The first thing that's very obvious that I want to show you is the foot. It is wave-like. It is extremely dense. It's actually hard to move in here. And so I am going to cut just a little small piece of this foot off. Notice how we have a coloration difference again. The bottom of the foot ends here, and this is a different organ. So we want to make sure that we're not cutting into another organ. Two ways to do this. One, you can use a scalpel. This is very dense. So I'm going to finish off with a pair of scissors, just so that I don't hurt the specimen or cut something underneath, because it is very dense. And so you can see that our foot is a very dense material within here. It's very muscular, which it should be. It's allowing for the movement of our clam. Do a cross section. So one thing that's really kind of neat about this, if you can see within the video, you can see the layering of the connective muscle tissue, and you can see the little holes going through where it's allowing nutrients to come in. That spacing is allowing for vascular movement of materials into and out of that foot, because we want to keep this very exposed. Remember, this does not have a closed circulatory system, so it will only give blood through a few ways. And so one of them, these are filter feeders, and so we're seeing this go through as well. So a couple things that I want you to see now that we're here is we can see these two little guys right here. And so these are going to be, got out of the system. These guys right here are going to be part of our mouth. And they're getting connected obviously to our digestive tract, which goes right in here. We know that we can see our part of our muscle. This is right here. And so that muscle is going to open and close our material as we go through. The next thing I want to look at before we go too crazy is our gills. These are the gills right here. Remember, they do not have lungs. So these are how we have oxygenated water pass over top of our gills, and it allows for them to breathe through this. And if you notice, we have a set on the bottom and on the top. And so we're going to remove the gills, again, very carefully. We don't need scalpels for the removal of the gills. We can use scissors. I really want you to see this part. Look at how aerated the gills are. And so we can see those individual sacs lining up. Air and water pass through those. I'm going to do a cross section. And you can see this paper thin. These are 2 sections. And so if we look, you can see the fluid kind of trapped in side of them. Their sections run vertically and not horizontally. And you can see that here. It's a very thin, almost paper-like substance. And they have 2 sets of gills on each side. And water will pass through them and oxygen will be collected as they pass through that. We do have, oh, very nice. So we can kind of see where this attachment points are. Here, we can see the connective tissue separating some of this stuff out. You can see very clearly right here, this is going to be a siphon. Really nice structure. Easy to see since we had a really good dissection on this one. For this one, it's going to be a little hard to see some of these because of the coloration of our mollusk, but right in here we can see this dark colored pigment. This is going to be our kidney. I'm going to remove some of this material here so we can see, oh, very nice, right here. These are what I was looking for. Now if I can prop them open so we can see them just a little bit more intently. And so this is what we're looking at as our heart. And so when we talk about an open circulatory system, this is our heart muscle. And this is allowing blood drains back to this and then it pumps out. And shells will usually sit like this, so it actually is draining back. So gravity is helping that out to go from there. We can see that our mouth is on this end, our anus would be on this end pointing out, and that sphincter or siphon muscle is connected right here, so this would shoot stuff out, not only water but waste products, and then this one would bring it in to our mouth. And this is known as our digestive gland. They don't necessarily have a stomach per se, they have a digestive gland, and I want to open that up so we can kind of see. So I'm cutting it away from the anus. Right there, that was the anus. Remove that out. Our heart is right on top, so I want to be very careful so I can separate this out later. And we're connected to the gills on the bottom side. Okay, so our digestive gland is here. We can see where our foot was attached to the bottom. And this is our digestive gland, kidneys being on the bottom side, digestive gland being here. And so one thing that's really nice about this is that the mouth feeds right into that digestive gland with intestines and stuff moving. Those are a little less complex than what we have within ours, but we're going to cut those open anyway. Yeah, really nice. You can actually see some stomach contents, which is what I was hoping for. I'm not cutting all the way through, I'm just cutting far enough so that we can lay it open. And so from here, we can now cut in. So a little bit of a tangled mess, but that's okay. We can see right here, this darkish brownish color, that is your stomach contents, or what we consider a digestive gland within this organism, the inside portion of it. The filtration portion is down at the bottom, and that's what we would consider a kidney system. We can see how, again, the openings for this are quite amazing, and I want you to see, yay! See our tube right there. This little tube is going to feed to the anus. And so that's expelling waste out. We would call that our colon or large intestinal system. They just have a single intestine, but this would be our large intestine. So I'm super happy that we got to see that one. And so that is right here. We can't see that externally. We have to look at it more internally for this. There is a coarseness to this. Oh, we can see on the outside here too. And part of this stuff right here is the preservative that I'm scraping off. It has nothing to do with the actual organism itself. That's just the preservative. So I'm going to put the digestive tract over there. And so we should be able to now look at what we have left in here. So again, this is another set of gills. They're attached. And then we can see still, oh, beautiful. And so we should still be able to see, yep, on the bottom side, this brownish line right here, this would be considered what we know as like the pericardial sac for us. Here again is that heart. It's broken up into atrium and ventricles just like ours. And we can see this would be like the aorta up here, leading to our atrium, and then our ventricle would be on the bottom side here. And so that's going to feed to the whole body. Again, it drains back in to that for the opening. This is this is our least complex. You'll notice that it does have a true coelom because I can actually pull this out. So it has a coelom. So now I'm just separating the mantle from the rest of the shell so we can still see that, and then we get this beautiful shell left afterwards. And so this is one of the simpler invertebrate organisms, and this is a bivalve. So remember that these guys are filter feeders, and they take their food in through their mouth, and it does expel through their anus from there. And that is our first invertebrate dissection.